All right, we're going to start right at the top here with me pausing here and asking you to try this problem. Take about a minute or two and see if you can fill in those missing pieces. So, first statements are, hopefully you found, copy pasted straight from the given. So we're going to say given. And good news, it's two pairs of sides. Pair of sides number 1, pair of sides number 2. So that sets us up in good shape. Then step 2 says, hey, we've got vertical angles. So it's up to you to pick out where the vertical angles are. And that's right here. We won't just say angle X so that we know exactly where which angles we're talking about. So we have WXV congruent to angle YXZ. So that we can tell apart which angle X we're talking about when. So those are the two angles that are the vertical angles. They're going to be the same. Therefore, that's a pair of angles. So we've got the triangles congruent, and hopefully you picked out your method, being our two sides, angle included between them. So that's going to be side, angle, side. And then our last step, well, it's what we're being asked to prove. It's angle V congruent to angle Z. Right? And we can check that. V congruent to Z. And our reason there will be C, P, C, T, C. Corresponding parts being congruent. Once we know the triangles are congruent, we know that angle V is congruent to angle Z. And CPCTC is our reason that sets up those sides and angles being congruent. Now, I want to take a look at one more example here. And it's another one that is fairly tricky because it involves looking closely at your diagram. So let's label out what pieces of information we're given. We have A, B, C, that is A into B through C. That's this angle right here. And then D, E, C, D into E out through C is that angle there. So we have these two angles being the same. And then C to B and C to E. C to B will be here, C out to B, and then C out to E. So if we're tracing out the two triangles that we're talking about, this is triangle number 1 that has that angle on that side. And then here is triangle number 2 that has that angle and that side. So these are the two triangles that we're looking at. Now, those triangles, this is where the tricky part comes in. Those triangles do not share a side, but they do share an angle, which is right here. So what we're going to say is that angle C is congruent to itself. And our reason is going to be reflexive property. So almost all the time we've been talking about common sides, but this time it's a common angle between those sides. But now that's good news because we have that last pair of angles that we need, and our side, which is right here, is included between our two angles, between that green and that red angle. So when we mark the triangles congruent, let's go triangle DEC congruent to triangle, well, D matches up with A, E reflects over to B, and then C stays at C. Our method, since the side is included, is going to be angle, side, angle. And then just like before, our last step is because those triangles are congruent, we look at A to B, congruent to D to E, and that matches up first two letters with the first two letters. So A to B, congruent to D to E, and our reason is going to be C, P, C, T, C, just like it was before. So we're still following all those same steps we had before. We started with our given. We always look at how we use our given. If it's perpendicular, that should tell us right angles. If it's midpoint, talk about what a midpoint means and what it does. If it's a bisector, what does a bisector do? Then look at the diagram. Look for those vertical angles, or look for that reflexive property. Then pick out your method. So that gives you a couple more examples to work from.